Hey guys, what's up? We're going to look at density. So density is defined as the mass per unit volume. It's how many kilograms there are per meter cubed of material. And it's really important and is used by engineers to help them determine which material to use in a different scenario. So let's have a look at a few different examples. We've got a table here of the different densities of materials. You can see that density varies greatly. Iron has got a really high density, 7,900 kilograms per meter cubed, and wood is not very dense, only 750 kilograms per meter cubed. So what does density mean in the real world? Well, if I have 1 meter cubed of wood, its mass would simply be 750 kilograms because it has a density of 750 kilograms per meter cubed. If I have 1 meter cubed of water, its mass would therefore be 1,000 kilograms. And if I had 1 meter cubed of aluminium, because it has a greater density, its mass is going to be 2,700 kilograms. So the mass of a material depends upon two things: the density and how much the volume of material that you have. And we see that in the equation for density. Density is the mass divided by the volume. The standard, the SI units that we use for mass is kilograms, and for volume we use meter cubed. Therefore, density is always measured in kilograms per meter cubed. I say always, that's by scientists, but in everyday life we often see volumes measured in centimeter cubed, and we have masses measured in grams. Therefore, you can actually see quite often density given in grams per centimeter cubed. And in your exam, they may give you density in kilograms per meter cubed or grams per centimeter cubed, and you've got to be able to use both. Right, so we use the letter rho, this Greek letter rho, which is a curly P. We don't use D because we use D for distance. So rho stands for density, and it's equal to the mass divided by the volume. If we want the mass in a calculation, we're going to cover up M. So M is equal to density, rho, times the volume. And if we want the volume of a material, we do the mass divided by the density, rho. It's a very simple equation to use. So let's have a look at an example. Here we've got a block which has a mass of 104 kilograms, and we've got its dimensions, 0.5 meters by 0.4 by 0.2. So if we want to determine the density of this block, we're going to use density is mass divided by the volume. We don't have the volume, so let's work that out first. Volume is length times width times depth. So we're going to do 0.5 times by 0.4 times by 0.2, and we get a volume of 0.04 meter cubed. We now have the mass and we have a volume, so let's work out the density. Density is mass divided by volume, which is 104 divided by 0.04, and that gives us a density of 2,600 kilograms per meter cubed. We're using the SI units in this example. In the next example, I've got a tennis ball, and you can see here that the mass is given in grams and we've got the volume in centimeter cubed. So we use the same equation, density is mass divided by volume, but we're going to use grams and centimeter cubed this time. So the mass is 60 divided by 150 centimeter cubed, and we get a density of 0.4 grams per centimeter cubed. So really important, you can either use kilograms per meter cubed or grams per centimeter cubed. So why is density important? One reason why it's important is to do with floating and sinking. And a more dense material will float on top of a less dense material. So let's have a look. Which of these substances in this table will float in water? Water has a density of 1,000. So the two things that are less dense are wood, which has a density of 750 kilograms per meter cubed, and plastic, which has a density of 920 kilograms per meter cubed. They will float. All the other materials, you've got iron and aluminium, they've got densities greater than water and they will sink. So this explains why things float and sink when you place them on top of each other when they're liquids. And you see this in a practical called a density column. where you've got a number of different liquids and sometimes even put solids in there, put a ping pong ball in here. And you can see that the most dense substance, the honey, which has a density of 1.4 grams per centimeter cubed, sinks to the bottom. And then you've got syrup, which has got a slightly less dense. On top of the syrup, you have fairy liquid, 1.1 grams per centimeter cubed, and it goes all the way up the column to the least dense, which if you've got a ping pong ball, which has a density of 0.1, so it floats on top of the alcohol, which itself is on top of the vegetable oil, and so on. So you have the most dense at the bottom, and at the top of this density column, you have the least dense materials. So it's a really nice visual way to see the effects of density on floating and sinking. Let's do a few more calculations. This question says, calculate the mass of a wooden plank that has a volume of 0.06 meter cubed. So mass is equal to density times by volume. We're going to use the density of wood, which is 750 kilograms per meter cubed, and we're going to multiply by the volume, 0.06, and that gives us a mass of 45 kilograms. And that is as easy as it gets with these questions. You use the formula, you put the numbers in, and you get your answer, and you just got to remember to include your units at the end. This is a slightly more difficult question, where we've got a bar of aluminium has a length of 3 meters, a width of 2 meters, and a depth of 1 meter. We're going to assume that it's a cuboid bar of aluminium. And what's its total mass? So we look at our equation again. Mass is equal to density times volume. We don't have the volume, so let's work it out. Volume of a cuboid is length times width times depth. So we do 3 times 2 times 1, and that gives a total volume of 6 meter cubed. So now we can work out the mass. Mass is the density of aluminium, which is 2,700, multiplied by 6 meter cubed, and that gives a total mass of 16,200 kilograms. It's quite a large mass. This next question is asking us to calculate a volume. What is the volume of plastic that has a mass of 230 kilograms? So we cover up V in our formula triangle, and we get volume is equal to mass divided by density, and we're looking at plastic. So the mass is 230, and we simply divide by the density of plastic, which is 920, and that gives us a volume of 0.25 meters cubed. Very, very simple and straightforward. Last one. We've got a cylinder of material which has a cross-sectional area of 0.15 meters squared. And this bar has a length, the cylinder has a length of 60 centimeters. If it has a mass of 711 kilograms, which substance is it? So the way we can identify the substance is by calculating the density, because the density is specific to the material. So density is mass divided by volume. We don't have the volume, so let's work that out. Volume is cross-sectional area multiplied by the length. The cross-sectional area was 0.15, and the length of this material is 60 centimeters, but we're going to use meters here because we're using SI units. So we do 0.15 times 0.6, and that gives a volume of 0.09 meters cubed. So now we can calculate the density. Density is the mass, which is 711, divided by the volume of 0.09. So the density is 7,900 kilograms per meter cubed. And if we look at our table, we can see that this material must be iron. So using the density, we've identified the material that we had. So in summary, density is defined as the mass per unit volume, and different materials have different densities. Those that are most dense will sink to the bottom, and those that are less dense will float on top of more dense materials. The equation is the most important thing to remember. Density is mass divided by volume, and that's where we get our formula triangle here. If we use in SI units, we use kilograms, meter cubed, and we calculate density in kilograms per meter cubed. And you've just got to be careful for when we use centimeter cubed, grams, and grams per centimeter cubed. That's it. Thanks for listening. See you all soon.